Hello, everyone. Welcome back. We are now into chapter 17. Or if you're thinking about our lab material, we are working on the beginning of the week 2 of the acid and base lab. Now, know that the form of that lab is going to change, but the concepts that are going to be expected from you are going to be very similar. And so this video should help get you started on that material. And so this is part 1. This is us preparing for titration. And so we're going to talk through some of the first steps that you have to do before you can begin titrating. So the first piece of any titration is that you have to make the solution of the thing that you want to learn about. And in this example, we are going to use sodium acetate. Sodium acetate is a solid, it's a salt, and the procedure we can think that the procedure tells us that we want to create 100 milliliters of a 0.5 molar solution. And so the first thing we have to do is figure out the mass of sodium acetate that should be used to create 100 mils of a 0.5 molar sodium acetate solution. Now, we've done this several times this semester. And so to do this, my first step is going to be to find moles. And so I want to make 100 milliliters of solution. I'm going to convert the milliliters to liters. And I'm going to use the concentration to find the moles of sodium acetate, the moles of sodium acetate that are needed for this solution. Moles of NaCH3CO2. Now that I know moles, I can use the molar mass to find the mass. And so I have 0.0500 moles. And the problem gives me the molar mass. In 1 mole, there are 82.0343 grams. And so I find that there's 4.102 grams of sodium acetate needed. Okay, so now I know what mass I need to weigh out and dissolve in water to be able to make this solution. Now, something to know how I'm going to organize this is that all of the videos in this series of videos for the titration are all going to be working with the same solution, so this 0.5 molar sodium acetate solution. So things are going to be consistent. This is just the first step. Nope, sorry. Okay, so how would we do this in the lab? Well, we would go and we would get a 100 milliliter volumetric flask. So this is a volumetric flask. And then we would go to the balance and we would weigh out our sodium acetate. And we would weigh out, and let's say that we weighed out we were good. We got 4.102 grams of sodium acetate, which is what we wanted. We would then add the sodium acetate into our flask. So we now have 4.102 grams of sodium acetate in our flask. And then we would fill our flask with water. So we will fill with water to the line. And then we will mix to dissolve the sodium acetate. This solution here now is 100.0 milliliters of 0.500 molar sodium acetate. Now, if you happen to use a different mass here, you can recalculate, you should recalculate the concentration that you have made by knowing that molarity is moles per liter. Okay, so that's what we would do in the lab. And now before we begin our titration, we want to know what the pH of the solution that we just created happens to be. Where are we starting? Well, so we have to first think about dissolving the salt in water, because that's what we just did experimentally. So when we put our NaCH3CO2 into water, it's an ionic species, so it's going to break up into its ions, making sodium plus CH3CO2 minus. And from last chapter, we know that our sodium is going to be neutral, and our acetate is a weak base. So now we have to set up the equilibrium with water. So my neutral species is not going to produce an equilibrium, but my weak base is. So I'm going to set up that equilibrium. This is a weak base. Base takes proton, and so I get acetic acid plus hydroxide. And so now, step 3, we have to say what is in solution. And at this point, what is in solution is only the acetate. And so at this point, we have a weak base. Now, to find the pH of a weak base, we need to use an ice table. And so step 4 is set up process to find pH depending upon what is in solution. So for us right now, we're going to set up an ice table. And ice tables use concentration, and so I'm starting with 0.500 molar of the acetate. Water doesn't matter. I have no acetic acid, and I have no hydroxide. And so my change is going to result in creating more products. So at equilibrium, I have 0.500 minus x, x, and x. And so I know that the Kb is going to be equal to x squared over 0.500 minus x. Now we know that the Kb is equal to Kw over Ka. And if we look up the Ka for acetic acid and we plug this information in, we get that the Kb is 5.56 times 10 to the minus 10. And so if I set up solve out my ice table, I have 5.56 times 10 to the minus 10 is equal to x squared over 0.5 minus x. And I can solve my quadratic equation, and I get that x is 1.667 times 10 to the minus 5 molar, which is equal to my hydroxide concentration. And so now my handwriting is getting big, so I'm going to zoom in a little bit. So now step 5, we need to find the pH. I know these problems are long, but you're going to get into the habit of this. And so the pH is equal to 14 minus the pOH. The pOH is equal to minus log of 1.667 times 10 to the minus 5. And so the pOH is equal to 4.778. And this gives us the pH of 9.22. Now, I like to try to sanity check my work. I have a weak base in solution. This tells me that my pH should be greater than 7. My pH is 9.22, and so I give myself a happy face. Okay, so what I want you to remember is that the key steps here is figuring out what is in solution and using that process for finding the pH. All of this right here, we've already done. This is chapter 16. So, and it turns out that figuring out that this is a weak base is chapter 16. We are just putting it together in an application. So make sure to keep your head on straight and really be thinking about what is in solution and how do I find the pH of that. Okay, so now for something a little bit easier. the last thing that we want to do is, when starting our titration and making our predictions, is figure out what volume of our titrant that we are going to need to use to reach the equivalence point. So what's happening here is that we have our burette, and we are going to put our HCl in our burette. And then we are going to have our flask, and in our flask we are going to have our weak base, our sodium acetate solution. And to measure this, we are going to have a pH meter. So weak acid, weak base titrations use a pH meter instead of an indicator to be able to monitor the course of this reaction. But the same thing is happening with the reaction that we've talked about in the past. And so we want to figure out when approximately the end point of this titration will be. And so the first thing that we need to do is understand the reaction occurring. And so in this case, we have sodium acetate plus HCl forming sodium chloride plus acetic acid. This is a standard acid-base reaction like what we learned last semester. And notice that we have going on here, we have a single arrow. This means that we are working with stoichiometry. Okay? And so to find the moles of HCl needed, we have to do stoichiometry. So now we want to find moles of HCl required to react with all the sodium acetate. So to do this, I'm going to start with my 10 milliliters of sodium. Okay, so we have 10 milliliters of sodium acetate. And I'm going to convert that to liters. And then I'm going to convert that to moles. And I'm going to actually keep going here. So this is moles of sodium acetate. And then I know that this reaction has 1-to-1 stoichiometry. So 1 mole of sodium acetate reacts with 1 mole of HCl. And so if I work this out, I find that I need 0.005 moles of HCl to be able to react with all of the sodium acetate. And so now, using these moles, I can find volume. And so I have 0.00500 moles of HCl, and I know the concentration of the HCl is 0.3 moles per liter. And I don't like my answers in liters. I like my answers in milliliters. So I'm going to do that conversion, and I find that it requires 16.67 milliliters of HCl to reach the equivalence point. Okay, so we're going to keep working on this from here, but this is how you begin to plan your titration. And in the next video, we are going to work to understand what is happening at the equivalence point of your titration. So remember, I have office hours, we have the tutors, and there are lots of resources on D2L. Please reach out as you need me.